Welcome again, Wildcats. So today we're looking at, Tuesday, solve systems by substitution and elimination. That's going to be on page 17. So if you would, pause the video and update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, solve system by substitution elimination. Notes on page 17, okay? All right, so substitution steps. Step 1, solve one of the equations for either x or y. Step 2, substitute the equation from step 1 into the second equation. Step 3, solve the second equation. Step 4, use the found variable in step 3 to find the other variable. So if you would, pause the video a moment and update your substitution steps. All right, now let's look at elimination steps. Step 1, place both equations in standard form ax plus by equals c. Step 2, determine which variable to eliminate. Step 3, solve for the remaining variable. And step 4, use the variable found in step 3 to find the other variable. So if you would, pause the video and update your notes. All right, so now that your notes are updated, let's look at our examples. All right, now in this video, I think it's important so you see all the examples, but just understand in class on Tuesday, I'm more than willing and definitely open to going over all the examples. You just have to let me know in class on Tuesday, okay? But like I said, I think once I start showing you one example, it's important you see them all. All right, solve each system by substitution. Now, when you do substitution, you want to make a table, okay? And you also want to color code your equation. So I'm going to make that equation yellow and this one blue. So this is y equals 2 parentheses x minus 1. And as always, flexure ruler. You want never come without a flexure ruler. It always comes in a flexible handy. All right, so let's take a look. Again, we're going to make a table, and you'll see why as we work the problem. Okay, and then x minus 4y equals negative 13. All right, and the reason why we want to color code is we're going to substitute y in for y. Okay, so this becomes x minus 4 parentheses 2 parentheses x minus 1 parentheses equals negative 13. And so I've color coded so you can see that this went in for y. Okay, now that you've done that, then you just go back to your pencil, which as always, the American pencil is the only way to go when doing Temple Wildcat Mathematics. All right, so now I'm looking at our steps. We're doing substitution. So step 1, we're going to solve one of the equations either for x or y. So that was already done. That was already solved. One of them is for y. Step 2, substitute the equation, which we did. Now step 3, solve the equation. Okay, so now we're into step 3. So we're going to solve for x. So you get x, we distribute, so negative 4 times 2 is negative 8, parentheses x minus 1 equals negative 13. Okay, now we distribute the negative 8, so you get x, and I'm going to put a 1 in there, 1x minus 8x plus 8 equals negative 13. Now we combine like terms, the x and the negative 8x becomes negative 7x plus 8 equals negative 13. Now, we're subtracting 8 from both sides. You get negative 7x equals negative 21. And then we divide by negative 7 from both sides, and you get x equals 3. Now, if you're a parent out there watching, you'll notice that I know there was some concern about showing steps. I've shown a significant amount of steps. Now, I didn't show the step here and here, but understand if I go over this in class, or if students have questions about it, I'll show those steps I did in the video, okay? All right, so now step 4 says use the found variable in step 3 to find the other variables. So we're going to use 3 into the first equation for x. So that's y equals 2 parentheses 3 minus 1. So 3 minus 1 is 2. 2 times 2 is 4. Now, one of the mistakes students forget is that that's not the solution. The solution is the point. So you actually want to write your solution as 3, comma 4. You actually have to write the point as your final solution. Okay? All right, so take, I don't know, a few seconds to finish example 1. All right, so continuing with substitution, let's look at example 2. All right, and again, I'm going to color code these equations. First one yellow, second one blue. So you have y equals 3x plus 2 and then 3x minus y equals 4. Now, at this point, what you might want to do is, again, in pencil, you might pause a video and try example 2. And then once you tried it, unpause, and then you can watch me as I work through it, and you can verify your conclusion. But if you're one of those ones that just likes to follow along, you just don't pause and follow along, okay? All right, so we're going to substitute y in for y, because we already noticed that step 1, it says solve for one of the equations for x or y. The first equation is already solved for y, so we're moving on to step 2, substitute the equation into the second equation, or substitute the first equation into the second equation, okay? So that becomes 3x minus, now y is 3x plus 2 equals 4. Well, that should be in blue. What am I doing? All right. Now, before we move forward, go back and look at your notes. We should have notes on solving systems. There's 3 possible solutions for solving systems, okay? So at this point, pause it and go back into your notes and find that, and then review that, okay? Okay, I'm hoping you did that, and you went back in your notes that said there's 3 types of solutions. 1 is one solution, 2 is no solution, and 3 is infinite solutions, okay? So let's see which one example 2 is. We've already seen one solution, so let's see what example 2 is. So here we have a negative in front of the parentheses. Let's make that a 1. If there's not a number in front of the parentheses, assume it's a 1. In this case, a negative 1. Okay, so we're going to distribute the negative 1. So negative 1 times 3x is negative 3x. Negative 1 times 2 is negative 2 equals 4. Well, 3x minus 3x cancels, it becomes 0, and you get negative 2 equals 4. Negative 2 will never equals 4. And if this ever happens, if the x's or y's are eliminated and you're left with a false statement, it's going to be no solution. All right, so pause a minute and finish up example 2. All right, now by now I'm hoping you realize the organization process here. We did one solution, we did no solution. So we're assuming that example 3 is going to be infinite solution. So let's see what that looks like. All right, and again, first step color code. So the first one's yellow, second one's blue. So x equals 1 divided by 3, y minus 2 divided by 3. All right, and then 3x minus y equals negative 2. All right, so step 1 is solve each equation for x, y. We already have one equation solved for x, so we move to step 2. Step 2 says substitute the equation from step 1. So now we're on to step 2. So we substitute this in, the x in, okay? So that is 3 parentheses 1/3 y minus 2/3 equals negative 2. Okay, so now we're into step 3. Solve the second equation. Okay, so let's solve this for y. So 3 times 1/3 is 1y. 3 times negative 2 is negative 6 divided by 3 is negative 2. Wait a second. There's a mistake here. This should be minus y equals. Almost made a mistake. All right. So that's 3 times negative 2 is negative 6 divided by 3 is negative 2. Minus 1y equals negative 2. Okay. So we know that 1y minus y cancels. And you get negative 2 equals negative 2. Okay, which when you eliminate the variable and you're left with the true statement, it's infinite solutions. All right, so pause for a moment and finish up. All right, now let's look at example 4. All right, example 4. All right, we're solving by elimination. Okay, so let's look at our steps. So step 1, place both equations ax plus by. Okay, well, this is a 1, this is a 1. We have both equations in ax plus by equals c. Now, step 2, determine which variable to eliminate. Okay, so it looks right here that I have a negative 4. Well, if I multiply this by positive 4, they'll eliminate. So I'm going to multiply the top equation by 4. Now, you really don't need a color code for elimination. Okay, so now, whenever you have an equal sign, you have to multiply that number by every term. Okay, so this becomes 4 times negative 2 is negative 8x. 4 times 1 is plus 4y equals 4 times negative 2 is a negative 8. Okay, now we just rewrite the second equation. And then step 3, solve for the remaining variable. Okay, so you're going to actually add and subtract vertically. So negative 8x and 1x is negative 7x. These cancel, become 0, equals negative 21. We divide negative 7 by both sides, x equals 3. And again, I didn't show the dividing by negative 7, but again, in class, if I need to, I can go back and do example 4 and show that step, okay? All right, so now step 4, use the variable found in steps 3 to find the other variables. So we have x. Now, it really doesn't matter which equation you plug it into, but I'm going to plug into the first one because there's no number in front of, or no, I'm sorry, I'm going to plug into the second equation because there's no number in front of x, okay? So then I plug in 3 for x in the second equation, so that's 3 minus 4y equals negative 13. Okay, so I subtract 3 from both sides, I get negative 4y equals negative 16. Divide both sides by negative 4, y equals 4. And then remember to write your solution, which is 3, 4. Now you might notice that example 1 and 4 have the same solution. That's because of the same equations. And this was done on purpose so you could see that substitution and elimination works both. You can do substitution and elimination on any system, okay? They'll both work, okay? And that's actually true for example 2 and 5 are the same and 3 and 6 are the same. So you can see that elimination and substitution can be done on either one. You can choose which one you want to use, okay? All right, so let's look at example 5. All right, example 5, okay? So step 1 says place both equations in ax plus by. Okay, well, ax plus by, And really I say plus, but as long as the A and the B are on the left and the numbers on the right, you're okay. All right, determine which variable to eliminate. Well, here I have a positive 6, but if I multiply this negative 3 by 2, I'll have a negative 6. Okay, so then they'll eliminate. So I'm going to multiply the top equation by 2. So 2 times negative 3x is negative 6x. 2 times y, that's a 1. So 2 times 1y is 2y. And 2 times 2 is 4. Remember, if there's an equal sign, you multiply, you have to multiply every term by that number. Okay? All right, and then we rewrite this second equation. So 6x minus 2y equals 8. Well, the x's cancel, become 0. The y's become 0. So you get 0 equals 12. And if both variables are eliminated and you're left with a false statement, then it's no solution. All right, so pause for a moment and finish up example 5. All right, let's look at example 6. All right, so again, you want to see which, step 1, place both equations in ax plus by, which we've done. Step 2, determine which variable to eliminate. Now, in this case, there's not one equation we can multiply a number, but we can multiply both numbers. So look at this 2 and negative 3, okay? If I multiply the first equation by positive 3, that will become a positive 6. And if I multiply the second equation by positive 2, that will become a negative 6, and those will cancel. So sometimes you have to multiply both equations by a number. And let's watch what happens. So 3 times negative 6 is negative 18x. 3 times 2y is a plus 6y equals 3 times 4 is 12. 2 times 9 is 18x. 2 times negative 3 is negative 6y. And 2 times negative 6 is negative 12. So we add vertically, add or subtract vertically. This becomes 0, this becomes 0. So you get 0 equals 0. Now, if the variables are eliminated and you're left with the true statement, it's infinite solutions. All right, so pause for a minute and finish that up. Now, I feel like this lesson's pretty straightforward, but if it's not, I understand completely if you want me to go over one of the examples or all the examples in class, okay? But at this point, you also might look, well, I've gone over the examples, you might try the assignment, okay? So it's up to you. But just understand, especially like number 3, I made a mistake, and that might have thrown you off. I understand completely, especially if you want to do example 3. But I'll go over any of those examples in class, okay? So with that, finish that up. Start your assignment. Don't start your assignment. You can decide on that. If not, be ready for Tuesday, and we'll go over this in class. All right. So with that, have a wonderful Wildcat day.